Hi everyone and welcome back to another lab. OSPF is a link state routing protocol that allows routers to dynamically learn routes by exchanging information with their neighbors. In this lab, we will focus on setting up OSPFv2 in a point-to-point network topology and verify neighbor relationship or neighbor adjacencies and route propagation. This is because OSPF behaves differently when configured on point-to-point links compared to other network topologies such as broadcast or multi-access networks. These differences stem from the nature of point-to-point connections, which involve only two devices, unlike multi-access networks where multiple devices share the same segment. So one significant difference is that OSPF skips the designated router or DR and the backup designated router or BDR election process on the point-to-point links. Whereas in broadcast or multi-access networks, OSPF elects a DR and a BDR to reduce the amount of OSPF traffic by centralizing communication between routers. However, in a point-to-point network, since there are only two routers directly connected to each other, the DR and BDR election is unnecessary. This simplifies OSPF operations and reduces configuration complexity. In addition to this, OSPF convergence is faster on point-to-point links because there is no need for the DR-BDR elections. OSPF neighbors can form adjacency as soon as they detect each other via hello packets. The absence of additional routers on the link also means fewer OSPF packets need to be exchanged, allowing the routers to synchronize their link state database more quickly. OSPF also automatically recognizes the point-to-point nature of the link based on the interface type, such as serial or Ethernet configured for point-to-point connections. So by the end of this lab, you will be able to configure OSPF-v2 on point-to-point interfaces and establish OSPF neighbor adjacencies between routers, verify OSPF adjacencies and routing tables, and ensure correct route propagation across the network. So again, as usual, we will go through the lab topology, the lab objectives, and then after that, I'm going to cover the lab tasks and then finally walk you through the lab solution. Okay, so regarding the lab topology, as you can see on the screen, we have three different routers. These will be used to connect multiple networks. So we can see router 1 is connected to router 3 and switch 1. Switch 1 is connected to a couple of PCs, PC1 and PC2, which are part of the 192.168.10.0/24 network. Router 1 is connected to router 3 via serial interface 0/3/1, and router 3 is connected to router 2 via serial interface 0/3/0. Router 2 is connected to switch 2 via Gig Ethernet 0.1, and switch 2 is connected to a couple of PCs, PC3 and PC4, which are part of the 192.168.20.0/24 network. So all routers, as you can see on the screen, will be configured in the backbone area, which is area 0, and each router will run the OSPF process and use the appropriate router ID as per defined from the playbook, and all networks should be advertised via the OSPF process. And just to let you know that all end hosts and devices in this lab are pre-configured with the appropriate IP address settings and are ready to go. So the objectives of this lab is to configure OSPF-v2 on multiple routers within a single OSPF area and establish and verify OSPF point-to-point connections. By the end of this lab, we will need to ensure that there is connectivity across all end devices. So for instance, PC1 should be able to ping PC2 as well as PC3 and PC4. Okay, so regarding the lab task, we will start by configuring the LAN interface on router 1 and router 2. This initial setup is crucial for ensuring that the local networks are properly connected to the routers. Next, we are going to initiate ping tests between PC1 and PC2, as well as between PC3 and PC4. This step will help us verify that the local area network or the LAN network configurations are functioning correctly and that the devices can communicate with each other. After the ping tests, we will then examine the output of each WAN interface on router 1 and router 2. This examination will allow us to understand the current state of the WAN connections before we proceed with further configurations. In step 4, we will configure the WAN interfaces with point-to-point encapsulation. Following the encapsulation, we are going to set the appropriate IPv4 addressing for all WAN interfaces. Next, we're going to move to step number 6, 7, and 8, where we will configure OSPF across all routers. And this configuration will enable dynamic routing within our network and ensure that routes are exchanged properly. After that, we will move to step number 9, where we are going to examine the output from multiple commands to help understand the OSPF configuration and the routing behavior of the network. This step is crucial for troubleshooting and ensuring that OSPF is working as expected. And then finally, we're going to move to step number 10, where we are going to perform connectivity tests between all end devices to ensure everything is functioning correctly, and successful tests will confirm that our configurations have been implemented effectively, and this will conclude the lab. Okay, so as usual, this is the moment where I ask you to pause the video and try this yourself to test your knowledge and skills. I have added the lab document in the video description, so you can go ahead and download it and practice at your own pace. I've also included a couple of packet tracer labs for you to download. You will find a pre-lab and a post-lab version. The pre-lab is for those who want to tackle all tasks from the beginning, while the post-lab provides the full lab solution. Okay, so I'm going to tackle the lab solution with the first task. And the first task, we're going to jump into router 1 and router 2 CLI to configure the LAN interface with the appropriate interface description, IPv4 address settings, and we will also need to enable the interface. So I'm going to go with router 1 first, and then I'm going to go to CLI, and from there I'll go to global config, and then I will issue the interface gig ethernet 0/1 command, and I will set the description first, and I will set it to link to switch 1. I will set the IP address to 192.168.10.254, and the subnet mask is going to be 255.255.255.0, which is /24. And then I will also need to enable the interface. So I'm going to say no shut or no shutdown. Now that we've done that, I'm going to perform some in-flight checks quickly. So I'm going to say show IP interface brief. And you can see this is the interface that we just configured. And you can see the IPv4 address that is assigned to that interface is 192.168.10.254. And right now is in the up state, which means layer 1 and layer 2 are good to go. So I will do the same thing on router 2. So I'll go back to my topology and I will go and select router 2. I will set the description and I'm going to say link to switch 2. I'll set the IP address to 192.168.20.254, and the subnet mask is going to be /25, which is 255.255.255.0. We will also need to enable the interface. And now let's perform some in-flight checks. I'm going to say show IP interface brief. And as you can see here, gig ethernet 01 has an IP address of 192.168.20.254, and right now is in the up state. Okay, so now let's jump into step 2, and we need to initiate a local ping between PC1 and PC2, as well as between PC3 and PC4. So I'll go back to my topology and I'll go to PC1, I'll go to desktop, command prompt, and from there I should be able to reveal the current settings, and I'm going to ping PC2. So I'm going to say ping 192.168.10.2. And you can see the ping is working as expected. Let's do the same thing for PC3. I'm going to say ping 192.168.20.4. And as you can see, we have reachability and connectivity between PC2 and PC1 and PC3 and PC4. Okay, so now that we have done that, let's move into step number 3, where we would need to check the WAN interface encapsulation across all routers. So I'll go back to my topology and go to router 1. And from there, I should be able to issue the command show interface serial 0/3/1. And right now, as you can see here in this line where I'm highlighting on the screen, it says that the encapsulation is HDLC. So HDLC stands for High Level Data Link Control. And the other type of encapsulation that can be used is the PPP or point-to-point protocol. So the PPP and the HDLC are two different protocols used for establishing point-to-point connections between devices, especially in the wide area network environment. While both are layer 2 protocols used to encapsulate data for transmission, they differ significantly in terms of features, compatibility, and functionality. So for instance, HDLC is a simpler protocol, and while it is an international standard, the version implemented by Cisco is a proprietary. This means that Cisco's HDLC can only be used between Cisco devices, limiting its interoperability with other vendors' equipment. In contrast, PPP is an open standard that can be used across devices from different manufacturers. This makes PPP more versatile, especially in mixed vendor environment where you may need to have Cisco devices on both ends of the connections. Also, one of the main advantages of the PPP over HDLC is its ability to support authentication mechanism. PPP includes protocols like PAB or Password Authentication Protocol and CHAP, which is Challenge Handshake Authentication Protocol, which provide authentication between devices to ensure secure communication. This feature is absent in Cisco's HDLC protocol. Therefore, if authentication is required, then PPP is the preferred choice, offering an extra layer of security to WAN links. So as we saw on the output from the command show interface serial 0/3/1, we can see that the default encapsulation is using HDLC. So now let's repeat the same thing on router 2. So I'll go to router 2 and I will issue the same command, but this time it's going to be different interface ID. So it's going to be serial 0/3/0. You can see that the interface is in the up state and the current encapsulation is HDLC as well. Let's confirm this with router 3. So I'll go to router 3 CLI. And I would say show interfaces serial 0/3/1. You can see is currently up, and the default encapsulation is also HDLC. And if I up arrow this and change the interface ID to 0, you can see that this one is also using the HDLC encapsulation. Okay, next let's move into step number 4, where we need to change the encapsulation method from HDLC to PPP. So I will start by router 3 since I'm on it. So I'm going to go to global config and I will set the interface ID, and I would actually need to use the serial interface. So I'm going to say interface serial 0/3/1. Let's tackle the link connects router 1 and router 3. So I will say the encapsulation, and if you question mark that to get the content sensitive help, you can see that you can use multiple technologies. And for the purpose of this lab, we will be using the PPP, which is the point-to-point protocol. So I'm going to say PPP. And then if you question mark that, you can then hit enter at this point. And you can see that the interface went down straight away because one end of the interface or one end of the link is configured with PPP protocol and the other end is still configured with HDLC. So both encapsulation must match in both ends. Otherwise, you're going to have problems forming layer 2 between each network. So I'm going to do the same thing for the other interface, which is serial 0/3/0, and I will configure it with PPP encapsulation as well. Now, if I issue the show IP interface brief, you would see that these two interfaces are up-down, which means the physical link is up, but layer 2 is not up. So I'm going to go to router 1 and I'll go to global config, and then I'm going to go to serial or interface serial 0/3/1, and I'm going to set the encapsulation to PPP. Now that is done, let's just make sure that the interface is in the up state. You can see that the interface is in the up state. And if we also issue show interface serial 0/3/1, you can see that the encapsulation now has changed to PPP instead of HDLC. Now I'm going to do the same thing on router 2. So I'll go to router 2 and I'll do the same thing. So I'm going to say configure terminal and then interface serial 0/3/0 encapsulation PPP. Let's do some in-flight checks. So I'm going to say show IP interface brief. You can see the interface is up now. And if I say show interface serial 0/3/0, you can see that the encapsulation is PPP, as you can see on the screen. Okay, I'm going to move to step number 5, where we need to configure all WAN interfaces across all routers. So I'm going to go to router 1, and I will go to global config, and then I will set the interface ID to serial 0/3/1. Let's set the description, and we're going to say link to R3. Let's set the IP address, which is going to be 10.1.3.1, and the subnet mask is going to be 255.255.255.252, which is /30. And then what I'm going to do, I'm going to enable the interface. I know it is already enabled, but I just like doing it for the sake of it. And then I will exit this. And we also need to configure a loopback interface 0. So I will say interface loopback 0. I will set the IP address with 1.1.1.1, and the subnet mask is /32, which is 255.255.255.255. And then I will hit end, and let's just do some in-flight checks. So I'm going to say show IP interface brief. And you can see that we have configured these two interfaces with the appropriate IPv4 information or details. Let's jump into router 2 and do the same thing. Going to say IP address 10.2.3.1. Subnet mask is going to be 255.255.255.252. And just enable the interface. And let's create a loopback interface. I'm going to call it 0. And let's set the IP address with 2.2.2.2 and /32. And let's just verify our configurations quickly, and you can see that we have configured interface loopback 0 as well as the interface serial 0/3/0. Okay, I'm going to jump into router 3 now. And I will start tackling the interface that connects back to router 1, which is going to be serial 0/3/1. I'm going to set the description. I'm going to say link to router 1. Let's set the IP address to 10.1.3.2. Subnet mask is 255.255.255.252. Going to enable the interface, and I am going to actually hit the exit command, and I'll up arrow to get to that command interface serial 0/3/0. And then I'll set the description to link to router 2. Let's set the IP address with 10.2.3.2/30, and then enable the interface. And after that, I'm going to configure the loopback 0 interface with IP address of 3.3.3.3. Subnet mask is 32. And we are done. Let's perform some in-flight checks. So I'm going to say show IP interface brief. You can see we've configured 3 interfaces. two WAN interfaces with the appropriate encapsulation method, which is PPP, and also we configured the loopback interface 0. Okay, let's jump into step number 6, where we need to go to router 1 and create an OSPF ID of 1. So I would say router OSPF 1. So we need to advertise the WAN network, the LAN network, and the loopback network. So I'm going to start with the WAN network. So I'm going to say network 10.1.3.0, and the wildcard will be 0.0.0.3. And we need to use the area 0 or the backbone area. I'm going to hit enter. And then after that, we'll need to advertise the LAN network. So I'm going to say network 192.168.10.0, and the wildcard is going to be 0.0.0.255, and is also going to be in the same area. And then finally, the loopback interface. So I'm going to say network 1.1.1.1, and the wildcard is going to be 0.0.0.0.0. We're also going to use the same area. So now that we've done that, let's jump into router 2 and do the same thing. So I'm going to create a new router OSPF ID of 2. And in here, I'm going to start advertising the WAN network first. So I'm going to say 10.2.3.0. And the wildcard is going to be 0.0.0.3. And it's going to be in the same area, area 0. We also need to advertise the LAN network. So I'm going to say network 192.168.20.0, and the wildcard is going to be 0.0.0.3, and it's also going to be in area 0. And then finally, the loopback interface or the loopback network, which is 2.2.2.2. So at this point, we can jump into router 3 and do the same thing. So I'll go to router 3 and also advertise all 3 networks. So I'll say router OSPF, and then we need to set the ID to 3. I will advertise the WAN network that connects to router 1 first. So I'm going to say network 10.1.3.0, and the wildcard is going to be 0.0.0.3. Again, we're going to use the backbone area, which is area 0. And then if we wait a few seconds, we should have a log message that indicates that there is a neighbor relationship between router 1 and router 3. And as you can see, we have received this, and you can see the neighbor ID is 1.1.1.1, which is the loopback of router 1. Let's do the same thing for router 2. So I'm going to say network 10.2.3.0, and the wildcard is going to be 0.0.0.3. It's going to be in area 0. And let's wait a few seconds. And as you can see, we also have initiated adjacency between router 3 and router 2, because router 2's ID or neighbor ID is 2.2.2.2, which is the loopback of router 2. Now I'm going to advertise router 3 loopback network. So I'll say 3.3.3.3, and then 0.0.0.3, area, oh, that meant to be 0 actually, area 0. I'm going to hit end. And then at this point, we have configured OSPF across all routers. So let's do some in-flight checks. So I'll go to router 1, and I would say show IP OSPF neighbor. So this command provides a view of all OSPF neighbors that are directly connected to the router, along with their current status and relevant details. So you can see this is slightly looking like a table. You can see this is the table header, and here is the data. And what you see here, this is the neighbor ID column, And you can see that the neighbor device ID is 3.3.3.3, which is router's 3 loopback interface. You can see this is the priority of the neighbor, which influences the DR and BDR election. As you can see right now, the status is in the full state, which is what we want. And you can see that there is no information indicates that there is a BDR or DR election, since it's a point-to-point link. So you would not see this information in here. You can see the dead time interval. This is the time remaining before the router considers the neighbor down due to the lack of hello packets. You can see the address column. This is the IP address of the neighbor. You can see this is the IP address that is configured on the interface serial 0/3/1. And this is the local interface through which the OSPF neighbor is reachable. Let's issue the show IP OSPF database. So I'm going to say show IP OSPF database. So this command is used to display the OSPF link state database, or LSDB, for the router. And the LSDB contains information about all OSPF routers and their links within a particular area. So what you see on the screen, if we were to examine this output, the first line that you see on the screen is OSPF router with ID 1.1.1.1 and the process ID is 1. So this is basically is the router's OSPF router ID and the OSPF process ID. The next line that you see on the screen is the router link states, and this is related to area 0. So all this information would be related to area 0. If we have multiple areas, then you will have multiple tables. So if we were to examine the table, you can see that the link ID is the identifier of the link, and that will provide information about the IP address of the router or the network. And we know, for instance, that the OSPF ID for router 1 is 1.1.1.1, and the same applies for router 2 and router 3. If we look at the ADV router, or the advertising router, this is what the advertising router that sends the LSA. So you can see that this LSA is being sent by router 1, this is router 2, and this is router 3. If we were to look at the age column, so that column represents the age of the LSA, indicating how long it has been in the database. Next is the sequence number, and the sequence number of the LSA, which is used to determine the freshness of the information. And then finally the checksum, and it is a value used to verify the integrity of the LSA. Next, let's issue another command, which is the show IP OSPF. Okay, so this command is used to display general OSPF information such as the OSPF process ID, the router ID, and the area configurations and the OSPF timers. It is very important when you troubleshoot problems that are related to OSPF. And as you can see from the screen, the first line indicates that the current routing process is OSPF1, which what we configured on router 1. And you can see that the current OSPF ID is 1.1.1.1. Also, we can tell that this is operating in the backbone area, or area 0, and the number of interfaces in this area that are participating in the OSPF process are 3. And you can see that the SFP algorithm has been executed 6 times. So one more command that I would like to show you, which is the show IP OSPF interface. That will give you an indication of all the interfaces that are participating in the OSPF process. So you can see the first interface is the serial 0/3/1. The second interface is the gig Ethernet 0/1. And the last interface is the loopback 0 interface. You can see here it does tell you this is the current network, or the internet address, or the current IP address is set to the IP address assigned to the local interface, and it does tell you that is part of the area as well. Here it tells you that it's part of which OSPF process. You might have multiple OSPF processes that are running simultaneously, but this one, it tells you that this interface is associated with process ID 1. You can see the router ID is 1.1.1 for the OSPF ID. You can see the network type here is point-to-point, and the current cost is 64. So this is quite important, especially when you troubleshoot issues between neighbors that are trying to form adjacency between each other. So the hello, the did, and the wait parameters must match both ends in order for the OSPF to form adjacency. So this command is very useful when you're troubleshooting issues that is related to OSPF. Also, you can see that is adjacent with neighbor 3.3.3.3, which is router 3. And if we were to look at the gig Ethernet 01, you will have similar information, and the same with loopback 0 as well. Let's quickly look at the routing table. So if I say show IP route, what we see here, this is the local interface or the local network. This is being advertised by OSPF. You can see the O here, which indicates it's being advertised by OSPF protocol. And you can see we've learned about the router 2 loopback interface, which is 2.2.2.2. We also learned about the router 3 loopback interface, which is 3.3.3.3. We also learned about the network between router 3 and router 2. So we've learned about all the networks. The only network that I can see that we haven't learned about is the LAN network for router 2. So let me go back to router 2 and see what is going on here. So show IP interface brief. Let's say show IP route. So I can see the network that is related to router 1. And I've got my own network here. Okay, let's look at the configuration quickly. Okay, I see. So I made a mistake here. So I actually need to go back to global config and go to router OSPF2. And I will need to negate that command. So I'm going to say copy, paste, and then I'll up arrow that. And that would need to be 255. And I would need to enable advertise the network, I mean. So we're going to end this and I will save the config. I'll go back to router 1, give it a few seconds and try again. So I'm going to say show IP route. And you can see that we have learned a LAN network from router 2. Okay, so let's move into step number 10, where we need to perform connectivity tests between PC1, PC2, PC3, and PC4. So I'll go back to my topology, I'll go to PC1, and then from here I would initiate a ping from PC1 to PC3. So I'm going to say 192.168.20.3. And you can see we have reachability between PC1 and PC3. Let's do the same thing for PC4. And I can ping PC4 as well. Let's jump into PC4 and try to reach PC1 and PC2. So I'm going to say ping 192.168.10.1. And I can ping PC1. Let's do the same for PC2. And I can reach PC2 as well. Okay, so we have reached the end of the lab, and that's it, folks, for this video. If you found this video helpful, please don't forget to give it a thumbs up, and if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. Remember, consistency and hands-on practice are key to success. So stay curious, stay inspired, and until next time, peace.